In this lecture, we are going to talk in more details about the basic data types, that is char, int, float and double. We are going to discuss about the range of these data types and also about the overflow and underflow regarding these data types. So let's get started. So in this program, I have declared 4 variables: character variable A, integer variable B, float variable C and the double variable D. So first let's talk about the character variable. So character variable name is A. So let me store a character question mark in this particular variable. So now let me try to display this variable. How do I display it? I just have to write printf A equals to %C is the format specifier for the character. So I just write that is A here. So it will give me the character, that is question mark. It should be displayed in the screen. So let me try to compile this code. So I'll just write gcc datatypes.c and then run this code. So I'll get question mark is displayed here as it is. Okay. Now a very important point to note here is each character is internally represented as an integer number. If you can recall, in one of our previous lectures, we have already discussed that each character is having a unique ASCII code, ASCII value, that's a number, that's a decimal number. So internally each character is represented as a decimal number. So you can say that character is actually treated as an integer number. Okay. So how do I print the ASCII code for this character question mark? So I can just write printf ASCII, let me display ASCII of my character %C is %D. So I'm trying to print the ASCII of C. So because ASCII code is an integer number, it's a decimal number, so I'm just writing %D here. So I'll just write the variable names A, A. That means if I print A using %C format specifier, I'll get the character as it is. And if I print it using %D format specifier, I'll get the ASCII code of that character. So let's check this out. Okay, compile this and then run this code, and you see the ASCII of question mark is 63. Alright, to know about the lower limit and the upper limit, the range of each data type, we can actually know that by using a header file limits.h. So I'll include this header file limits.h. So it contains all those lower and upper limits of data types. So I'll come here and try to print the lower limit of char first. So I'll just write lower limit of char is %D because that's a number, and I'll just write char char underscore mean. So this is in capital letters. So this symbol, this constant is already defined in limits.h. Okay. So let's similarly, I'll just copy this here and then paste it here to find the upper limit also. Okay. So the upper limit of char is char max. Okay. So now let me compile this code and let's run this. And you see the lower limit is -128 and the upper limit is +127, meaning the character is internally represented here as the signed number, signed integer number. So writing character is as good as creating a signed integer number. Okay. Now you can actually create an unsigned character as well. Okay. So for that there is one specific qualifier called as unsigned. Okay. So if I write unsigned char ch, the size is still 1 bytes here, but now the range will change. So how do I find the range of the unsigned number? So to find the lower limit and the upper limit of unsigned character, there is a constant defined in the limits.h. Generally lower limit of unsigned number is not defined because lower limit of unsigned number is 0, right? So to find the upper limit of unsigned number or unsigned character, I just paste it here as it is. Okay. So I just write upper limit of unsigned character is, I'll have to write uchar max. Okay. Lower limit is 0. Unsigned char lower limit is 0. And for upper limit, we'll just print it here like this. So let's compile this code now. Okay. And execute this. So it is 255. So you can say that unsigned is ranging from 0 to 255 and signed is ranging from -128 to +127. So whether it is signed or unsigned, the size is always 1 bytes for a character. The range may change, but the size is always fixed to 1 byte. So now let's talk about integers. Here I've already defined integer variable B. So whenever I just write integer, I mean this is a signed integer. Similarly, whenever I just write character A, it is a signed character. Okay, so there are two qualifiers available, two keywords available. Those keywords are, one is signed and one is unsigned. So whenever you would like to create a signed character, you can simply write char a, that would be a signed character, or you can write signed char, let's say x. So now this becomes a signed character. And if you want to create an unsigned character, you have to write unsigned char, say q. Okay, so this becomes a signed character, this becomes an unsigned character. So this signed and unsigned are qualifiers. They add value to our data type. So this will make sure that this character q is an unsigned character, and signed will make sure that this character x is a signed character. Okay, but if you just write char a, it will by default be a signed character. Okay, similar with integer. Whenever I write int b, it is as good as writing signed int b. So this is a signed integer. Okay, so let's first of all find out the size of this integer. So I'll just write it like this: printf size of int is equals to %d. Let's see in my machine what is the size of int. We have already seen this in our previous lecture also. So let's compile this first and let's try to execute this. Size of integer is 4 bytes. In most of the machines, size of integer is 4 bytes. In some of the machines, it can be 2 bytes as well. Okay, so size is done. Now let's try to find the lower limit and upper limit of integer. Okay, signed integer. So I'll just copy this as it is. Okay, and I can write lower limit of integer, int, lower limit of integer or signed int, both are same thing. Okay, integer or signed int. Whenever I say int, it means signed int. Okay, so I'll have to write int mean, int underscore mean in capital letters, and this is int underscore max. Okay, so now if I just compile this code here, you'll be able to see lower limit is -2147483648. So this is the lowest value you can go up to, and this is the highest value that you can store in a integer variable. Okay, now let's try to find the lower and upper limit of unsigned integer. So let's copy this first and then paste it here. Lower limit of unsigned int is what? Is 0, right? So I can directly write it is 0 because we know that this is a fact. Okay, lower limit of any unsigned number is 0. Upper limit of unsigned integer is, you write uint underscore max, u meaning unsigned. So now if you see here, let me compile this code first and execute it. So you see here the unsigned integer upper limit is given as -1. Now there is a small problem here, right? So %d is actually used for printing the signed integer. So if you want to print the unsigned integer, there is a format specifier called as %u. Okay, so here I give the format specifier %u to correctly print the unsigned number. So whenever you are trying to print the unsigned number, make sure you use this format specifier %u. Okay, so let's compile this again, clear this screen and run it one more time. And now you see the upper limit of unsigned integer is displayed here correctly. Okay, so this is how you can actually print the lower limit and upper limit of integers. Now let us try to summarize this. So we have already seen for signed character, size is 1 byte, lower limit is -128 and the upper limit is +127. Now you may be wondering, how did we get this lower and upper limit value? Now if you can recall, in one of my previous lectures, we have already discussed that whenever you are talking about the signed number, and if each number is represented using n bits, the bit size is n, there are n number of bits for representing that number, then the range would be, for signed integer, would be from -2 to the power n minus 1 to +2 to the power n minus 1 minus 1. Okay, so if we just go with this one, so let's talk about the signed char. Okay, here it is 1 byte, so number of bits is how much? 8 bits, right? N is 8. So the range for signed integer would be -2 to the power 8 minus 1 to 2 to the power 8 minus 1 minus 1, that is -2 to the power 7 to 2 to the power 7 minus 1, which actually comes to be from -128, this is -128 to this is +127. So this is how you get the range for signed number. Now similarly for unsigned number, how did I get this range? For the unsigned number, the range that we have already discussed in one of my previous lectures. If you have not gone through that lecture, please go through it once. Okay, it is from 0 to 2 to the power n minus 1. Okay, so this would be 0 to 2 to the power n, here is obviously 8, 2 to the power 8 minus 1. So this is from 0 to 255. That's how I get the range here, 0 to 255. With the similar logic, here you can use n as 32 bits, okay, and then you will be able to find the range of signed integer as well as range of unsigned integers. I hope you are clear on how to find the range of signed and unsigned values. So now let's talk about the floating point numbers. Now let me just copy this code to actually repeat the same for the float, okay. So I'll go here, size of float, because size is an integer number, so I can just write size %d itself, okay. Now how do I print the lower limit of float? So because I'm printing a float value, so I'll have to use the format specifier f, %f, and upper limit of float, again the format specifier is %f, okay. So lower limit I'll print it as flt mean and upper limit is flt max, okay. Now let me compile this code. So it is saying that flt max is not declared, okay. Now very important point to note is that this flt min and flt max are not available in limits.h. So I need to use a new header file here because that is defined in a header file called as float.h. So if I want to find this constants value float max and float min, I have to use the header file float.h, okay. So let me just compile this again. This is how I compile and execute it. So I see the float number here, float mean and float max. If you see here, the lower limit is 0 and the upper limit is coming to be a big number. Lower limit is coming to be 0 because by default the number of digits printed after decimal is 6. So actually it's a very small number, 0.0000000 something. So to actually print the value, let me print the value in a scientific notation. So if I want to print the value in scientific notation, I'll have to use the format specifier %e. I can use either %e, that is e small letters, or e capital letter, whatever is fine. So let me use e small letter and capital letter, both of them here. So let me compile this code, that is gcc datatypes.c, and then run this code. Now you will see the lower limit is 1.17 into 10 to the power, e stands for exponent, 10 to the power minus 38, that is the very small number, 0.000000, that is minus 38, okay. So you know how many decimal places are there, and this is e to the power 38, that means 10 to the power plus 38. So this is a very big number, okay. This is how you find the lower limit and upper limit of a float. Now let's do it for double. So I'll just copy this here. For double also it's stored in the float.h header file, so no need to include any extra header file. So double. So size of float, by the way, is 4 bytes, okay. So let's see size of double, how much it would be, double. So similarly lower limit of double, let me print in scientific notation, so I'll use %e here. Double is, so I'll write dbl for double, dbl, okay. Here also dbl mean and dbl max, okay. These are defined in the header file float.h. So let's try to execute this, and you see the range is 2.22 into 10 to the power minus 308, that is the smallest number that it can hold, and the upper limit is 1.79, that is almost equals to 1.8 into 10 to the power plus 308, that's the big number that it can hold. Now for float, the format specifier is %f, and for double it is %lf, note it down, okay. And to print float and double in scientific notation, you can use %e, okay. And the size is 4 bytes and 8 bytes respectively, and this is the lower limit and the upper limit for double, for float, and this is for double, okay. Now how this lower and upper limit of float and double is being derived, we can actually do the derivation how it is done, but it would be out of scope of this course, so we'll just take this note for now that this is the range, okay. We are not going to go into the derivation how it's being derived, but it is possible that we can actually derive these values as well, okay. Now let's talk about overflow and underflow, right. Now you know what is overflow. Let's say you're having a bucket, right, where you can place water. So if you place water beyond the capacity of the bucket, it will overflow. Now in the case of, let's talk about signed character. If I talk about the signed char, okay, so the range is, the lower limit value is minus 128 and the upper limit value is, okay, plus 127. If I want to store a number that is bigger than plus 127 in a signed char, that would be an overflow. It will actually overflow this. Okay, so that is not allowed. If you try to store, if you have to store something bigger than plus 127, then maybe you have to go for unsigned char, because in signed char will only be able to hold maximum of value of plus 127 and a minimum value that it can hold is minus 128. If you try to go below this, if you try to go and store a number that is less than minus 128. Let's say you're trying to store the number minus 263. Minus 263 cannot be stored in the variable signed char because you are now into underflow. Okay, if you try to store the number less than minus 128, that's underflow. If you try to store the number more than plus 127, that is overflow. So whenever you are trying to decide what would be the type of a variable, what would be the data type, in that case, please make sure that you have selected the right data type which will be able to accommodate your values. Okay, that's about the overflow and the underflow. So in this lecture, we have learned about different data types and about their sizes, range, and most importantly about the underflow and overflow. Same concept of underflow and overflow applies in float and double as well. Okay, the maximum value, it can't go beyond the maximum value and it can't go below the minimum value. Okay, that is what needs to be taken care of. So that's all for this lecture. Stay tuned.